Welcome back to a course on mathematics of finance. We have been discussing about the concept of effective rate and nominal rate of interest. Let us continue the discussion on the effective rate and nominal rate. We have seen some ideas to calculate the effective rate, which is the percentage per annum when it is compounded half yearly, periodically, okay, in several periods for a year. And when it is compounded continuously, the formula to find out the total amount is a times of a is p times of e power in. These are the things that we have seen in the previous lecture. Let us start today's lecture with this problem. In this problem, it is given that a bank pays interest by continuously compounding interest to investors. Okay, so continuous in the sense we'll have to make use of that e power, that thing, right? Emily invests rupees 20,000 in the bank. So, given the principal is 20,000, okay, and the interest rate is 15 percentage per annum, which is compounded continuously. How much will she gets after 10 years? So, N is going to be 10 and R is going to be 15 and P is going to be 20,000. So, with which we'll have to calculate the requirements. Solution starts with the given information. Given principal is 20,000. Rate of interest is 15 percentage. If rate of interest is 15 percentage, then I would be 15 upon 100, which is 0.15, and N is 10 years. So we have these things. The total amount to calculate in this case, since it is compounded continuously, we shall write amount as p times of e to the power in. This is because interest is compounded continuously. So this is what we have, right? We shall substitute the given informations into it. We'll have p is 20,000 and e to the power I is 0.15 and n is 10. So which is going to be 20,000 times of e to the power 1.5. So we shall calculate what is e to the power 1.5. Right, so it is e to the power 1.5. So it is 4.481689. And if you multiply this with 20,000, we would get a rupees 89,633 rupees 78 paise. Right. Now let me tell you how to do this calculation on calculator, because here we have written e to the power 1.5 and we have directly I have written this thing. But when you type this in calculator, you have a option for this ln, right? So when you press shift and press this one, you will get simply e. You don't need to type power symbol and proceed with this. Simply type 1.5 along with this. Okay, this is how you need to type in scientific calculator to get this value, right? So once you do this, you will get this amount. Let us move to the next problem. Sorry. In this problem, it is given that if a depositor gets this amount from a bank, so this is the total amount. He is getting this amount from a bank which pays an interest of 10 percentage per annum compounded continuously. How much did he deposit 11 years ago? So the N is going to be 11 and R is going to be 10 percentage. So with which we'll proceed and see what is happening. So we are given with the total amount is 3,04,166 rupees and R is 10 percentage. If R is 10 percentage, then I is 10 upon 100, which is 0.1, and then N is 11 years. We know that P is 8 times, sorry, A is P times of e to the power in, since interest is compounded continuously. Right, and so we shall substitute the given informations into it. 4166, which is p times of e to the power 0.1 into 11, so which is going to be p 11 times of zero point 0.1, which is simply 1.1. Okay, and e power 1.1 is going to be approximately p times of 3.004166, and if we need p value, that is 3004166 upon 3.004166. So here itself we shall see what can be the result, right? But still, if we want our calculator to do the requirements for us, we shall do it, and we found that it is going to be one, if I am not wrong. So we have these things. It is going to be 6, if I am not wrong. So this is what he invested. Here we have 30 lakh. Yeah, right. So he has invested 10 lakh, and that 10 lakh amounted to 30 lakh 4,166 rupees in 11 years. Right. Let us move to the next problem. Actually, before this, we will see. Before looking at this problem, we will see what do we mean by depreciation and all. What do we mean by depreciation? What is the need of depreciation? And before seeing these things, let us recap the things that we have seen. Okay, actually, we have started with mathematics of finance, and initially, money is worth, right? Money value gets changed with respect to time, and that is why we get more amount for the same money that we have, and that extra money we call it as interest, right? When we gain something in terms of money, we call that as interest, right? Whereas if we give someone else, that is not gaining, right? But it is gaining for the other people. The same idea, the calculation. Okay, actually in interest, what we have done, we have calculated a certain percentage of money, and we add it up or subtract. This was the case, right? So till now we have just added. Suppose we talk about the concept of discount, there also what we do, we just calculate a certain percentage of value and we subtract it. That is discount. Depreciation is also the same kind. Even here, what we do is that we are going to calculate a certain percentage of money, and we are going to reduce from the original value. Okay, depreciation is calculated for what kind of things? Is it going to are we going to calculate depreciation for money? No. Depreciation is calculated for some goods or assets which usually loses its value with respect to time, like a vehicle, machinery, buildings. These kind of things loses its value as time passes. Depreciation is calculated and the money is kept separately, or its value is reduced from the original value of the asset that we have, in order to maintain these kind of things are maintained in order to meet the expenses when we are in a need to replace the actual thing that we have. Okay, so this is a part of accountancy, but still here what we are going to do is that we are going to calculate the depreciation value in terms of interest calculation. Okay, when I say interest calculation, we are actually calculating the percentage of a certain value, and we are going to subtract here. Okay,
In interest calculation, we just added things up. In depreciation calculation, we are going to subtract things up. Okay, whenever you heard of the term depreciation, technically speaking, there are 8 types of depreciation. Okay, out of which most of us have heard of the straight line value method and written down value method. Straight line value method is the one in which the same amount is deducted every year, just like the same amount is added every year in simple interest. Exactly the same idea is followed in straight line method, whereas the written down value method is the one which is similar to that of our compound interest. Suppose initially we buy a machine at rupees 10,000, let us say like that. Okay, when we calculate depreciation for the first year, we are, let us take the case where we are calculating 10 percentage, which means we will calculate 10 percentage of this 10,000, which is going to be 1,000 rupees, and we will reduce that 1,000 rupees from this 10,000, and the machinery value becomes 9,000. Okay, whereas in the second year we calculate 10 percentage of this 9,000, and we will reduce that 900 from the value of the machine at present, and it is going to be 8,100. Right, this is how the calculation took place. And how do we do it for a large number of terms? Simple, we have the total amount formula. A is P times of 1 plus R upon 100 to the power n in compound interest calculation. In the place of R, just replace minus R, that is P times of 1 minus R upon 100 to the power n, and that would give you the present value of the machinery after a certain years n, where the depreciation is calculated at R percentage per annum. Let us see few problems on it.
In this problem, we are asked to calculate the depreciation, the rate of interest. Okay, R value is 10 percentage. Value of the machine was commenced from 58,750. We'll have to calculate for 3 years. Okay, so let us start the solution. From the given information, what we are going to take as P is 58,750, R is 10 percentage, and N is 3 years, right? And we are asked to calculate the machine value. So that we represent by A, and it is P times of 1 minus R upon 100 to the power N, and P value is 58,750, and 1 minus 10 upon 100 to the power 3, so which is going to be 58,750, and this is 0 0.1. When we subtract 0 0.1 from 1, we get 0 0.9 to the power 3, and when we calculate this value, we will get, sorry, times of 58,750, and that gives me rupees 42,828.75, which is the value of the machine after 3 years. Right? Let us move to the next problem. Here it is very well given that a machine depreciates each year by 10 percentage. Okay, good. So our value is 10 at the beginning of the year. At the end of the fourth year, so we have to consider when n is 4, its value is 1,31,220, which means here they have given A value. A value is 1,31,220. N is 4. R is given, that is 10. We'll have to calculate the P value. So we start with this. A is P times of 1 minus R upon 100 to the power n. A is 131,220, which is P times of 1 minus 10 upon 100 to the power 4, which is P times of 0 0.9 to the power 4. Therefore, P is 131,220 upon 0 0.9 to the power 4. So 131,220 divided by 0, sorry, 0.9 to the power 4. and that gives me 2 lakh. So initially the machine was bought at the price of 2 lakh. Right? Let us move to the next problem. Here it is given that a machine is purchased for 15,000. So P value is 15. The depreciation is 6% per annum for the first 6 years. Okay. And for the next 6 years, it is 7% per annum. What is the value of the machine after 12 years? So this is quite tricky. It seems to be tricky, right? This shall be done in two ways. Let us go. Let me explain you both ways. Okay. P value is 15,000. N value. Okay. Two ways. Let me write the first way in red color. Okay. N is 6 years. For the first 6 years I am doing, and R is 6 percentage. Okay. uh, so the amount will be after 6 years. What is it going to be? It is 15,000 my times of 1 minus 6 upon 100 to the power 6. So it is 15,000 times of 1 minus 0.06 to the power 6. As of now, we don't know what this value is, but we shall calculate this thing, right? So this is for the first 6 years. The next 6 years, the principal will be this amount, right? Hence, so this is for first 6 years. Then for next 6 years, what is it going to be? This is our principal value. Okay, and 1 minus 7 upon 100 to the power for the next 6 years, right? So it is 15,000 times of 1 minus 0.06 to the power 6 and 1 minus 0.07 to the power 6, and if we calculate these things, we are done. Okay, the other way is directly writing these things. Okay, we know when we have to reduce something, we'll have to subtract. When we have to increase something, we just have plus here. So this is the primary difference that we all know for sure. So directly we shall write amount as 15,000 times of 1 minus 0 at 6 percentage for 6 years, and then 7 percentage for next 6 years. We shall directly write this. Let us suppose. Okay. Uh, so in both the ways, we are going to get the same thing. The one way is just calculate it. Here I have not done the calculation. If I would have done these, both the ways look different slightly. But since I have not done things completely, this looks similar. Okay, and this is why or this is the way through which I can motivate you people. And okay, now do this. Let us do this calculation. 1 minus 0.06 is going to be 15,000 times of 0.94 to the power 6. So it is 15,000 0.94 to the power 6, and that gives us this value. Okay, now what we do is that we substitute this value here and do this, and this is going to be 0.93 to the power 6. So along with this, we just multiply 0.93 to the power 6, and that gives us 66.95.08. So this is the value of the machine after 12 years. The direct way of calculation just leads us to amount is 15,000, 1 minus 0.06, and that is simply a 0.94 to the power 6 and 0.93 to the power 7. And in a simple step, in a single step, we may do this calculation. That is the idea. Power 6. So here also we are going to get the same. Right? Thank you.